RC phase shift oscillator. This circuit is an example of an RC phase shift oscillator. An oscillator is a circuit that produces a continuous wave without needing an external input signal. This circuit produces a sine wave. First, let us understand the purpose of the circuit. The main goal of this circuit is to generate an alternating signal at a fixed frequency. In this case, the frequency is around 1 kilohertz. Now let us look at the main parts of the circuit. The circuit has three important sections: the amplifier section, the feedback network, and the power supply. Let us start with the amplifier section. A transistor is used as an amplifier. This transistor increases the strength of the signal. It also introduces a phase change of 180 degrees. The transistor is powered using a direct current supply of 20 volts. Resistors connected around the transistor set the correct operating point so the transistor works properly. Now let us understand the feedback network. The feedback network is made using three identical resistor and capacitor. Each pair produces a phase shift. Each stage shifts the signal by about 60 degrees. Together, all three stages produce a total phase shift of 180 degrees. Now let us combine both effects. The transistor produces 180 degrees of phase shift. The RC network produces another 180 degrees of phase shift. When these are added together, the total phase shift becomes 360 degrees. This means the feedback signal is in phase with the original signal. Because the feedback is in phase and strong enough, the circuit satisfies the condition for oscillation. As a result, oscillations start automatically. Now let us talk about how the oscillation starts. At the beginning, there is a small amount of noise in the circuit. This noise gets amplified by the transistor. The amplified signal passes through the RC network. The feedback signal returns to the transistor input. This cycle repeats again and again. Slowly, the signal grows until stable oscillations are formed. The output signal is taken from the transistor output through a coupling capacitor. This capacitor blocks direct current and allows only the alternating signal to pass. The output is connected to a measuring device like an oscilloscope. On the oscilloscope, a smooth sine wave can be observed. Now let us understand the frequency. The frequency of oscillation depends on the resistor and capacitor values used in the feedback network. If the resistor values are increased, the frequency decreases. If the capacitor values are increased, the frequency also decreases. Using equal values makes the frequency stable and predictable. Now let us summarize. This circuit generates a sine wave using feedback. The transistor provides amplification. The RC network provides the required phase shift. The power supply provides energy. Together they form a stable RC phase shift oscillator. This type of oscillator is commonly used in audio signal generators. Laboratory experiments, low frequency signal generation, educational demonstrations.